All right, ladies and gentlemen, today we are going to all learn different ways to set up and solve a proportion. This correlates to the standard that you see listed below. The first thing we need to do, looking at this proportion, 2/5 equals 8/20, is understand what a proportion is. A proportion is two ratios that are equal, and if they are equal, they're said to have a proportional relationship. So we're going to examine a little bit more about some of the relationships between the different numbers when we have a proportion. So first of all, there's a relationship between the first terms and the second terms in each ratio. We also have the relationship between the cross products. And whenever you examine fractions, two equivalent fractions have equivalent cross products. Now, when we're looking at a ratio like this one, sometimes it's hard for us to determine what the relationship is between the first terms and the second terms. So we may have to look within each individual ratio. This might make it a little bit easier to understand. These are some of the ways that a proportion has a relationship between the different numbers. Let's examine different methods that can be used to solve these proportions. So here we have example 1. The ratio of boys to girls in history class is 4:5. I'm going to underline some key components here. First, we have boys to girls. Okay, since boys is listed first, then the 4 corresponds to boys. And since girls is listed second, the 5 corresponds to girls. So, how many girls are in the class if there are 12 boys? I'm going to circle this one in green. Girls is what we're trying to find, and we know that there are 12 boys in the class. Explain. The first thing that'll help you in solving a proportion is setting it up correctly. And the way to set up a proportion correctly is by really thinking about what words go with each ratio. So if we're going to write boys to girls, because that's what's given in our example, then this is one side of the equal sign, and the other side should be the same, boys to girls. You'll notice the blue, which is the original ratio that's given to me, is written on the left, and the green is written on the right. We have the ratio of 4 boys to 5 girls. That is my original ratio, and I'm trying to find out how many girls there will be when there are 12 boys. So notice how writing the words on the line with the ratio helps me to determine what numbers I'm putting on each line. The blue stands for the original ratio, and the green is the new ratio. Now, once you have that written, if you want to simplify it, just like the one before, all you have to do is take out the words. And here we have 4 to 5 equals 12 to question mark. Let's look at some methods we can use to solve this. The first method is the foolproof method. You multiply the cross products and solve using inverse operations. So let's examine this method here. If we multiply the cross products 4 times x, we get 4x. And when we multiply the cross products 5 times 12 here, then we get 60 once I move to my next step. Now, what do I do to solve this problem? You've probably done this before, but using inverse operations. If I'm multiplying 4 times x, how can I reverse that? Well, the inverse is to divide both sides by 4. The division property of equality says that if I divide one side by 4, then I can divide the other side by 4, and the equation, or both sides of the equation, will remain equal. Now all I have to do is simplify this. I can cross cancel the 4's, and that leaves me with just 1x. And x is equal to 60 divided by 4, which is 15. This method is the great method to use anytime you have decimals or fractions or some numbers that don't work very well together. Let's look at some other example methods.
Your attention, please, Claire.
The next method that we have here is to determine a scale factor, or the relationship between the original ratio and the new ratio, and then use the scale factor to find the unknown value. We can find scale factor by taking the new over the original. Well, the new term was 12. As you can see, it's color coordinated green, and the original was 4. We put 12 over 4, and when you simplify that, we get 3. So that tells us that we're going to multiply by 3. We look at the relationship. Here you're multiplying by 3. So I just take 5 times the scale factor, 3, and I get my new value of 15. And finally, the third method. Sometimes numbers don't work so well together. In this case, they work pretty well together if we look at method 2. But they also have a relationship between the numbers within each individual ratio. So determine the relationship between the numerators and denominators within each ratio. If you can do that, you can use this to solve the problem. In this case, I would have used method 2. But what happens when you have a problem that's a little bit more challenging? We may not be able to find out what 18 times what equals 27. But if we look at the other relationship, we can easily see that 18 divided by 9 is 2, and 27 divided by 9 is 3 to solve that problem. Well, I hope one of these 3 methods helped you out with solving proportions. See ya!